Hello and welcome. We explore the matter and we learned about its properties. Now it's time to venture deep into the matter to understand its construction. So if we have a sugar cube and we grind it, a single grain of sugar will have the same color and taste of the sugar cube. Similarly, if we to break the matter to the smallest part that retain its property and characteristic, that will be the molecule. And in today's lesson, we will study the molecule and its properties, the relation between temperature and physical state of matter, how temperature change the matter from solid to liquid to gas, and the types of molecules. So as we say that the molecule is the smallest part. So if we imagine that this is matter, and if we break it to the smallest part, we will end up with molecule. So molecule is a building unit of matter, or the smallest part of matter which can exist freely and it has the properties of matter. So what are the properties of matter? First, molecules are in continuous motion. There are intermolecular spaces among the molecules. There are attraction forces among the molecules. So as we see from the experiment that the violet color spread gradually through water, because the color dissociate into particles that spread through the water in all directions. So the color spread or diffuse into the water. The molecules of the color gradually moved through the molecules and through the water. That because the matter in continuous motion and the molecule are in continuous motion. So why a drop of ink spread through the water? Because the molecule of ink are in continuous motion in all direction among the water molecules. They keep moving, they always moving. And that's why when we leave a perfume bottle, we smell it all over the room, because the particle of the perfume spread and move across the air through the whole room. Because the molecule of perfume are in continuous motion and they keep the properties of perfume. So second property, there are intermolecular spaces. So let's do this experiment.
Welcome to this experiment. We will prove that the molecules of a substance have interstitial spaces between them. In front of you is a graduated cylinder, water and alcohol. Put an amount of water in a graduated cylinder and then add an amount of ethyl alcohol to it, then determine the volume of the mixture formed.
So we have two cylinders, one will fill with water and the other will fill with alcohol. So let's put 40 water and also 40 of alcohol. Suppose we have put in two cylinders equal volume of water and alcohol. They add up to 80 centimeters cubic. So let's add the water to the ethyl alcohol and see
We notice that the volume of the mixture is less than the sum of the volumes of water and alcohol, because some of the alcohol molecules have spread in the interstitial spaces between the water molecules. We conclude that there are spaces between the particles of matter called interstitial spaces.
So the actual volume is less than the default volume. Why? Because there is intermolecular spaces between the water that the ethyl alcohol entered those intermolecular spaces. So the volume of the mixture is less than the default volume because some of the ethyl alcohol molecules are distributed, moved in the spaces that are found among the molecules of water. We call these intermolecular spaces found or existed among the matter intermolecular spaces. So why the volume of a mixture of water and alcohol is less than the sum of their volume before mixing? Because some molecules of alcohol get in the intermolecular spaces among water molecules. So the disappearance of a little amount of table salt when put in a beaker containing water, because the table salt dissolve in water. The molecules of salt get into the intermolecular spaces among the water, spread into the intermolecular spaces among water molecules. Third property would be that there is attraction force among the molecules. That's why it's difficult to break a piece of iron, but it's easy to divide an amount of water. So it's difficult or hard to break a piece of iron because there are attraction force among the molecules, and those attraction force are very strong in solids, but the attraction force among the molecules are weak in liquids. So the intermolecular force are the forces that bind the molecule together. So for example, in the solid state, they have definite shape and volume, fixed shape and volume, because they have narrow intermolecular space. As you see, the spaces between the molecules are very small, and that causes a very strong intermolecular force. There are great force that bind the molecules together. So the molecules are relatively fixed in their position. But in the liquid state, they have defined shape but indefinite shape, because they have intermediate intermolecular space. So they have weak or slightly weak intermolecular forces. So they take the shape of the container. But the gas, as you see, they have indefinite shapes and volumes because they have very large intermolecular spaces. So they have very weak intermolecular forces. So the molecules are completely free. So the molecule of solid have limited vibration motion. They vibrate in their position. But the liquid are looser or freer. The gas are completely free. So as we look here, the solid, we have definite shapes, and notice that their molecules are fixed in their position and they're slightly vibrating in their position. But liquid, the intermolecular spaces are slightly large, so they have slightly weak intermolecular forces. But the gas, they're completely free due to their weakened or very weak intermolecular forces.